Today everyone, we're going to discuss you the lesson 2 of calorimetry. So the evaluation, problem solving making, direction. Based on your knowledge in this lesson, we will going to make a 3 problem solving question in heat loss system and 3 problem solving in heat gain system. So first, we're going to learn what are the signs. Where we have the M is mass, and the C is specific heat capacity, and Ti is initial temperature. Tf is final temperature, and this triangle with a big T is change in temperature, and Q is heat energy. Now let's proceed to the problem number 1. A 100 grams of water with 4,190 joules per kilogram degrees Celsius at 50 degrees Celsius was filled into 875 grams of boiling iron at 90 degrees Celsius. The final temperature of the iron and water is 100 degrees Celsius. So, what is the specific heat of iron? So first we're going to write the given. Water. We put the initial of W, and now the mass of water is 100 grams, and we convert it into kilograms, and it is 0.1 kilograms. And the specific heat is 4,190 joules per kilogram degrees Celsius, and the initial temperature is 50 degrees Celsius, and the final temperature is 100 degrees Celsius. And how to get the change in temperature is where we're going to minus the final temperature minus initial temperature. So 100 degrees minus 50 is equal to 50 degrees Celsius. So there we have it. And the iron we have here, we put it initial I to determine as iron. So the mass is 875 grams, and we converted it into kilograms. We have 0.875 kilograms. And the specific heat is missing. We just put question mark. So the initial temperature is 90 degrees Celsius, and the final temperature is 100 degrees Celsius. And we will going to minus the final temperature minus initial temperature, and 100 degrees Celsius minus 90 degrees Celsius is equal to 10 degrees Celsius of change of temperature. So now we're going to proceed to the solution. So the Q loss formula is Q loss is equal to mass times specific heat times the change of temperature. And we put a letter W here as the water. So first we're going to write the given. So first is the mass is 0.1 kilogram, and the specific is 4,190 joules per kilogram Celsius. And the change in temperature is 50 degrees Celsius. So first we're going to gonna cancel the kilograms. So cancel here, this one, and then we're going to cancel the specific heat. Then we will going to multiply 0.1 times 4,190 joules. Then we have here 419 joules, and we just copy the 50 here because it's already cancel out. So it's only 50. Then we're going to multiply 419 joules times 50 is equal to 20,950 joules. So next, we going to find the Q gain. So the Q gain formula is mass times specific heat times change in temperature, and we put letter I here, which indicate the iron. So we will just gonna copy here. We put it here, the 20,950 joules is equal to mass times specific heat times change in temperature. So next is going to write 20,950 joules is equal to mass of 0.871 kilograms times the specific heat times the 10 degrees Celsius of change in temperature over the 0.875 kilograms and the 10 degrees Celsius kilograms. 10 degrees Celsius. So we were going to cancel out first. Cancel here, cancel here, cancel, cancel. Then we have here. So it's 20,950 joules over the 8.75 kilograms. We just multiply this one, 0.875 kilograms times 10 degrees Celsius. And we have here the 8.75 kilogram degrees Celsius. And it is equal to specific heat because we have already canceled out this one. So the only remaining is this one, the specific heat. Then we will going to divide 20,950 joules divide 8.75 kilogram degrees Celsius, and we have here the answer, which is 2,394.29 joules per kilogram degrees Celsius. So we have here the answer, which is the specific heat of iron is 2,394.29 joules per kilogram degrees Celsius. Now let's proceed to problem number 2. At 25 grams of ice with 2,090 joules per kilogram degrees Celsius at 120 degrees Celsius was put to the 50 grams of coffee at 30 degrees Celsius. The final temperature of ice and coffee is 40 degrees Celsius. What is the specific heat of the coffee? So first we're going to write the given. We have here the ice and we put big I. And the mass is 25 grams and we converted it into kilograms and we have here 0.25 kilograms. And the specific is 2,090 joules per kilogram degrees Celsius, and the initial temperature is 120 degrees Celsius. And the final temperature is 40 degrees Celsius, and the change in temperature is 80 degrees Celsius. While the coffee, we put big E. And the mass of it is 50 grams, and we converted it into kilograms, and we have here 0.05 kilograms. Then the specific heat is missing, so we put it question mark. Then we have here the initial temperature is 30 degrees Celsius and the final temperature is 40 degrees Celsius. And then how to get this one? The change of temperature, we will going to minus the final temperature to the initial temperature. So 40 minus 30 degrees Celsius is equal to 10 degrees Celsius. And also here 40 degrees Celsius minus 120 degrees Celsius is equal to negative 80 degrees Celsius. So, let's proceed to the solution. So, first is we're going to have the formula of kilos is equal to mass times specific heat times the change of temperature, and we put big I here as the sign of ice. So the next is we're going to write the given. So the mass is 0.025 kilograms times 2090 joules kilogram degrees Celsius of the specific heat, and the change temperature is negative 80 degrees Celsius. So we will going to first cancel out the kilograms, then the specific heat. So the remaining is we're going to multiply the 0.025 times 2090 joules is equal to 52.25 joules. And we just copied the remaining